you guys were dying to email me about the fact that they sent this viral patient home with.
I know. It was in Washington Post.
So have I talked to you about how dangerous it is to give everybody antibiotics? And so now this is the point. We're sending somebody home with antibiotics. This is where you have just moved in entirely the wrong direction, and you've placed so many other lives at risk. And you know something? This is something that I'm teaching you guys in undergrad, for Christ's sakes. Do antibiotics work on viruses? Not even close. The guy was not showing signs and symptoms of a bacterial infection. He was showing signs and symptoms of a viral infection. And any practitioner that is not lazy and is well schooled should say, that's a virus. I'm not going to give you any antibacterials. And in terms of sending him home, I guess there's some misconceptions as to whether he lied about where he was from, or I guess some of the people didn't tell the other people at the hospital where he was from, and that information didn't get passed down to the department well. It is laziness, stupidity, and greed. That's what drives this world, I guess. Yes.
At what point a sample of any of his, I don't know, tissue or body fluid should have been taken and examined for gram-negative, gram-positive, or for whatever it needs to be examined for?
Right. You should always get a culture right away. I culture everything. And I'll tell you the reason I do that. If you come in and you've got signs and symptoms of a bacterial infection, the reason why I get a culture and send you home on antibacterials is because then if the culture comes back with something that I didn't anticipate, I can have the nurse call you at home and say, you know something, they have changed your prescription. Could you go back to CVS and could you get this other prescription because this is the organism that we're fighting? Do you see that that's the right thing to do in the world? All right, so let's talk about fomites. Let's talk about destroying organisms on these fomites. Ready? So here's some words that you'll need to know for the next exam. So here's decontamination, the destruction, removal, or reduction in microbes. If you are going to wear this apparatus in a Tyvek suit and you're going to wear all this stuff and you're going to come in contact with the patient, you need to go under a decontamination protocol before you start taking it off. Because in removing this, can't you get exposed to what's on the outside of it? So the decontamination procedures are typically what you'll see, and that's how I'm using that word in a sentence. Next is antisepsis. These are disinfectants, or we should say chemicals that are applied directly to exposed body surfaces. Disinfection, however, is the process to destroy pathogens on inanimate objects. And I gave you an example of an inanimate object. It starts with the letter F. Fomites. And how do we spell that? F-O-M-I-T-E, not F-O-A-M. So F-O-M, because everybody spells it fomite like the word foam. F-O-M-I-T-E, fomite. Countertops, surfaces, doorknobs, windows, candles. Sanitation is just simply mechanically removing. It's interesting because hand sanitizer is really misnamed because you're not mechanically removing things from your hand. You're using alcohol to destroy the organisms. Would you like me to use the word sanitation in the perfect sentence? The sanitation department comes by and removes your garbage. They don't spray your garbage cans, do they? They don't spray your house. They don't spray your front lawn. They don't use any chemicals. They're just removing, right? I would have to say that hand washing is a good example of sanitation because you're taking running water and soap and removing the microbes so they go down the drain, right? Sterilization, of course. I told you what sterilization is. You know what it is. My question for you is that when it comes to sterilization, what is the organism that has to be destroyed in order for us to consider that an item is sterile? Endospore-forming bacterium. Anything less, we don't call it sterile. All right. Degermination is not bold. It's a term that we don't use in the hospital. Okay. All right, so all these are in your PowerPoint. They're bold, and they're going to be in your next exam. Okay. Bless you. Who did that? Who did that? So we could go after the cell wall. Is that right? Cell wall that's made out of So we could try to destroy the cell wall with chemicals. We could try to disrupt the cell membrane, because you know the cell membrane is not made of peptidoglycan. The cell membrane is made of a phospholipid bilayer. So we could use a different chemical to try to disrupt that. Did you know that soap does that? Soap can destroy some weak cell membranes, not your cell membranes, but some bacterial cell membranes. Certain soaps could do that, like triclosan. Okay? Or the cellular synthetic processes. We did talk to you about the Krebs cycle, didn't we? Electron transport chain and glycolysis. You could try to use chemicals that will disrupt that process. I'm sorry, I'm saying the wrong thing. Synthetic processes. What I'm talking about is transcription, translation, DNA, and RNA. There are chemicals that could target that. That's what I meant. You can also get some chemicals that disrupt metabolic processes, but we'll get to that a little bit later. But these are the four that I want you to think about when it comes to the modes of action. Because in this next slide right here, let's see, it's this slide right here that uses all those technologies to cover all the ways that we destroy things on inanimate objects. So I'll just go back for 2 slides real quick and explain what this is. I'm also showing you that there are some chemicals that can actually denature proteins, causing proteins to unfold. When proteins unfold and they take a shape like this, they're no longer functional. They can't work anymore. Yeah. All right. And this is, of course, soaps that can destroy cell membranes. This is not a cell wall, is it? It's a cell membrane, correct? Okay. All right, so I'm going to go through all of these different ways that we can destroy organisms. The first thing we're going to talk about, and I definitely want to get done before we leave today, is called the steam autoclave. How many of you have ever worked with a steam autoclave before? Okay, the dentist, of course, my dentist has a little tiny steam autoclave because he has little instruments. And I always walk into his office and I go, look at that little baby autoclave. So look, I go, sometime when you come to my office, you can see big stuff, big tools, not little baby tools like you use. And then he says, go ahead and sit in that chair now. All right, so the autoclave. Here's what's important. It's not just an oven. It's not just an oven. We're going to show you what we do with this. When we talk about moist heat versus dry heat, in order to hook up an autoclave, not only do you have to have a power supply, you have to have a water supply. Because it's an oven that has water that makes steam. Steam is very, very important. Let's take a look at these 2 ovens. Let's take a look at this one where there's moist heat. Let's take a look at this one where there's dry heat, like the oven that you use to cook in your home. If you used 121 degrees Celsius and you were going to try to destroy, and you were going to try to sterilize something, which means we're going to destroy Bacillus anthracis, right? 121 degrees Celsius, you could do it in 15 minutes if you had steam. If you didn't have steam, look at that number. So tell me why I can't use this at the hospital.
Time-consuming, energy consuming.
Time-consuming. Let's just give you a perfect example. Patient's getting off the table, big tray of instruments, getting washed, getting put through this little mechanical washer. Now she's putting them into the autoclave. She's shutting the door, and she says, scrub your hands. These are going to be ready in 10 minutes. If she says, scrub your hands, it's going to be ready in 600 minutes, then I'm going to go get some lunch and don't even bother to go get the next patient. But if we're going to be ready in 10 or 15 minutes, we can actually do them in 10 minutes because we don't use 121 degrees. There's a higher temperature, which I'll discuss with you. So now I can call for the patient, get the patient on the table, get anesthesia in here. I'm going to scrub my hands. Let's get going. We got 8 cases to do today. We don't have 600 minutes between each patient.
So does it mean that the moist heat penetrates the cell wall, or?
It means that the moist heat actually raises the temperature and raises the pressure, which does enable better penetration. Without the moist heat, it would take a long time for the heat to penetrate that cell wall. You're absolutely right. Let's show you something else that's interesting here. Again, the moist heat versus the dry oven. Let's take a look at Bacillus, right, which is capable of forming endospores. 121 degrees. 1 minute to kill the endospores. Not the actual vegetative cells, but just the endospores. We can kill those spores in just 1 minute. Bacillus subtilis, 121 degrees, we would need 2 hours to kill the endospores. And remember, when you're handing me my favorite pair of Metzenbaum scissors, I'm assuming that there's nothing on those scissors, no viruses, no bacterium, and no endospores, right? So, what we want to think about now is what pressure does for us, what the steam under pressure does for us. Did you know that right now, the pounds per square inch in this room, on your skin, on you, it's not 0, it's 15 pounds per square inch, right now, in this room. When you look at an autoclave, it says 0. When you have the door open and you're looking at it, it says 0. That's because the autoclave says 0 and 15 are the same. When you close the door and the dial now reads 15, it's really 30, right? When the dial reads 15, this will give you a temperature of 121 degrees, which is, this is